All right. Welcome to my math podcast where we all love math a lot. And yeah, we're basically going to be going over chapter 10, vocabulary. So the first thing that we have here is the measure of central tendency. Now, typo, but the numbers are pieces of data that can represent the whole set. So like the ones that we learned were mean, median, and mode. Those are a few. And we'll learn about those in the next couple of slides. So the mean is basically all of the values or information that you've gotten from your set of data added up together and divided by the amount of values. So as you can see in this example here, there's 5 people. They've added all their heights, which are in centimeters, and the number of all their heights added together in centimeters divided by the amount of people here is the mean. And the mean, as you can see right here, is 168 centimeters. Now, the median, it is the middle value of a set. So here you can see that this median is 6. But here, since it's an even number, you took the 2 middle numbers and you took 4 and 5, and basically you divide them by 2, and 4 plus 5 equals 9, and divide that by 2 is 4.5. And basically, before you do the median, you have to arrange it in numerical order first. So, yeah. Now, the mode, it's basically when you have a piece of data, it's the number that appears most often in it. So, as you can see here, there's the number 639666593. And as you can see, the 3 appears twice, 5 appears once, 9 appears twice, but 6 appears 3 times. So 6 is the mode, and there can be more than one mode. So if, say, 5 also appeared 3 times, then 5 and 6 would be the mode. So the mode is limited to just one. Now the frequency table. The frequency table basically shows its values with tally marks, as you can see here. So these are basically the scores, and these are the tallies. Like, they could be used to record points and stuff like that. Now, a bar graph it shows the data with bars, and it makes comparisons, but basically what's special about a bar graph is that the information is more precise or discrete, which we used to describe it in math class. But so basically here it's 4. So the grades, like 4 students have an A. So it's specific because it's not like 4 through 6 students have an A. It's just 4. It's like 4. And basically it puts specific numbers instead of putting groups of numbers like 20 to 30 or stuff like that. And that's why there's a space between the bars, because there's nothing connecting 4 to 12. But if it was like 4 through 11, then these two would be touching. A bar and a bar graph, the bars don't touch each other because there's no in between values. Now for a histogram, it's different because the data has been organized into equal intervals. So like unlike the bar graph, the information isn't specific. Like it's not just focusing on one age. It's not just focusing on people who are like 5 here. It's focusing on people who are like 0 to 5 and 6 to 10 and 11 to 15. Now notice in a histogram, like between the numbers on the edges, like how do I say this? It's not like 6. It's not like 5 to 7, but it's like 5 to 6, 10 to 11, 15 to 16, 20 to 21. So basically, for a histogram, you can't put like just 5 to 7 and then 10 to 13. Like the reason that they're connecting is because the numbers, uh, basically the number, I don't really know how to explain it, but how to word it properly. But yeah, I hope that you get what I'm trying to say. So basically, the numbers kind of connect, and that's why the bars are, well, the intervals connect, and that's why the intervals are connecting. And also, the intervals are equal. Like, it's not like 0 to 5 and then 7 to 20. Like, there's a 5 space between each interval. And now here we have the range. It's basically you take the greatest and the least number in your data. Like here, the least is 3 and the greatest is 9, and you get the difference between that. So the difference in this data, the range, is 6. Now we have the quartile. It basically divides the data into 4 equal parts. And so these are each quartiles. There's the lower quartile, which is so there's the lower quartile, there's the second quartile, which is basically just the median of the overall data, and then there's the third quartile, or the upper quartile. Now, the measures of position divide the data set into like 4 groups. Some, like there's the second quartile, and then there's like the minimum, there's the first, there's the lower quartile, there's the upper quartile, and there's the maximum. So basically here, you could see like this is Q2. It's basically, sorry, it's basically the median, like overall median of the data. Now this is the median of the lower quartile, and then this is the median of the upper quartile, and then the minimum would be like the least number, which so this would be the minimum, and then the maximum would be 15, so this would be the maximum. Now, the lower quartile is the median of the lower half, and the upper quartile is the median of the upper half. So say the upper half, if we split them up perfectly, if the upper half numbers were 2, 3, and 5, the median of the upper quartile would be 3. And if the lower quartile was like -5, -3, -2, then the median would be -2. And now the interquartile range, it's the difference between the upper and the lower quartile. So this is the lower quartile, and this is the upper quartile. And so basically here it's 64, and here it's 77. And we divide 64 from 77, and we get 13. So this is the interquartile range. Now, the outlier, basically on the book, it says more than 1.5 times the interquartile range, but I wouldn't say go too deep into the specifics, because usually when you see your data, you can tell what's like the outlier. It's basically if you have a bunch of like So we have gas prices and like per gallon, and one of them is like $1 per gallon, and then it jumps to like $5 per gallon, then $6, then $7, then $8. Then you'd obviously know that the $1 per gallon is the outlier because it has a $4 difference, while the others just have like a one or a two. And here, yeah, basically all these numbers, these two would be the outliers. No, never mind, sorry. This is a negative. This would be the outlier since it's very lower. It's a lot lower than these numbers. Yeah, it's easy to tell. And yes, it's over. This is the chapter 10 vocabulary. And yeah, I hope that this helps you all understand it better. And then, yeah,